Okay, I have a more complicated example here now. If I was going to graph something like this, I could say, let me pick some of the x values and y values based on different values of t. And so if I take something like 0, I'm just going to take 3 values to give you an idea. If I take the cosine of 0, I get 1, so this would give me 5. The sine of 0 is 0, so this would give me 0. The cosine of 90 degrees, or pi over 2 radians, is going to be equal to 0, so that gives me 0 here. And the sine of 90 degrees is 1, so 5 times 1 would give me 5. If I take the cosine of pi, that's all the way over in my unit circle, all the way over here. The cosine is -1, so this would give me -5, and the sine would be equal to 0 once again. And so if I were going to graph that out here at 5, 0, at 0, 5, and then at -5, 0, I would have something that goes like that. This would be my initial point. This would be my terminal point, and I can see something like that. Again, when you use the grapher, you can see it put in place, but it's a half circle. How would I eliminate this parameter? Well, that's a little bit more of a challenge because I can't very well solve just for t. I'd get arc functions, and I really don't want to do that. But I can do this. If I said x squared plus y squared, that would give me 5 cosine t squared plus 5 sine t squared. When I simplify this, I'd get 25 cosine squared t plus 25 sine squared t. Factor out of 25, I get cosine squared t plus sine squared t. Guess what? We know that's equal to 1. So that parameter ends up completely dropping out, and so I can get this thing to equal x squared plus y squared equals 25. That is a circle. So that is a full circle. Again, I can't limit just the top half. So I would have to, in the domain, say something where x is between -5 and 5, and y is greater than, I guess I'd, say y is going to be greater than or equal to 0, and less than or equal to 5. So that's a limitation for this particular example. So that's a way to eliminate the parameter when I have trig functions.